Hello viewers, we have another question on quadratic. Okay, the first question here is find the set of values of k for which the equation x squared plus kx plus 2k minus 3 equals 0 has no real root. When k equals 7, the root of the equation x squared plus kx plus 2k minus 3 equals 0 are alpha and beta, where alpha is greater than beta. And also we have write down the values of alpha, beta, and alpha, that is alpha plus beta, and then alpha, beta, that is sum of roots. And this will be what? Product of roots, using what we call VIETA'S formula. Okay, and when a quadratic equation has no real root, what it means is that the value of the discriminant, okay, is negative or less than 0. Okay, so and also we want to form an equation with integral coefficient whose roots are alpha over beta and beta over alpha. Lastly, we want to also prove that the difference between the roots alpha and beta will be equals to square root of 5. Okay, so now the first question, okay, is for us to find the set of values, okay, for which the equation, that is the associated equation, has no real root. So of course we know that this is the equation we are giving. We are giving x squared plus kx plus 2k minus 3. Okay, now this is the associated equation. Now when compared with the general quadratic form of it, that's a quadratic equation. So when compared with ax squared plus bx plus c equals to 0, we know that the value, now a in this case will be 1, okay, b will be what? K, and c will be 2k minus 3. Okay, now for a quadratic equation, like I said, to have no real root, okay, so for no real root, let me write it this way: for no real roots, okay, discriminants, remember this is called discriminants will be less than 0, or we can say discriminant is negative. Okay, and what is discriminant? Don't forget that discriminant is a capital Greek letter for delta, okay, and it is a quantity, okay, which represents this expression, that is b squared minus 4ac. So when it is less than 0, when discriminant is less than 0, that means the associated equation has no real roots. So in this case, we are going to what? We are going to substitute the values of b, a, and c into this and set it less than what? 0. So we know that b is what? K. So don't forget we are using, so k square, so this will be k square minus 4 times 1, okay, multiplied by c, which is 2k minus 3. Okay, this is 2k minus 3. So we have 2k minus 3 less than 0. Okay, so this will be k square minus, now 4 times 1 is 4, minus 4 multiplied by 2k, that will be minus 8k, minus 4 multiplied by minus 3, that will be positive 12, less than 0. So let's write this the left hand side, okay, in factored form. So the factored form for this quadratic expression on the left will be, we know that the factors of 12, okay, that when added together will give us the middle term, will be 6 and 2. So that will be k squared minus 6k minus 8k minus 6k minus 2k plus 12 less than 0. So that this will be k into k minus 6, okay, minus 2 into k minus 6 less than 0. So this will be k minus 2, then k minus 6 less than 0. So that k minus 2 less than 0, or k minus 6, okay, less than 0. So k will be less than 2 or k will be less than 6, so that the set of values for which the associated equation is x squared plus kx plus 2k, okay, minus 3 equals to 0, has no real roots. Okay, so we're going to have, it's going to be 2 less than k, then less than 6. Or we can also write it this way: k is such that 2 is less than k, then less than 6. So this is the answer. Okay, the set of values, okay, for which the quadratic equation has no real roots. So that's it. All right, the second, now also we have here that when k equals 7, the root of the quadratic equation are alpha and beta, where alpha is greater than beta. So what they want us to do here is to substitute the value of k. Okay, so when k is equals 7, okay, by substituting the value of k into x squared plus kx plus 2k minus 3. Now we have this equation x squared, this will be 7x, 2 times 7, that will be 14, minus 3 equals to 0. So the equation will be x squared plus 7x plus 11 equals to 0. So this is the equation. Okay, now the second question, all right, is for us to write down the values of alpha plus beta and alpha beta. So the values for alpha plus beta and then alpha multiplied by beta. So that's when we have to use the VIETA'S formula. So using the VIETA'S formula, okay, using the VIETA'S formula, okay, we know that sum of roots will be negative b over a, and then the product of roots will be what? C over a. So using this equation, we know that the value of a is 1, the value of b is 7, and the value of c is 11. So the sum of roots will be 7 over minus 1, and that's minus 7, while the product of root will be 11 over 1, okay, which is what? 11. So these are the values. So we can then say that alpha plus beta equals to minus 7, and then alpha beta equals to 11. So that's the second, this is the answer to the second question. All right, so form an equation whose integral coefficient whose roots are alpha over beta and beta over alpha. So C, to form an equation, okay, with alpha over beta and then beta over what? Alpha. Okay, so we know that sum of roots will be alpha over beta plus beta over what? Over alpha, which can be simplified to alpha square plus beta square over the product of alpha beta. And this can be further simplified to, the square of the sum of alpha beta, okay, minus 2 alpha beta over what? Alpha beta. And now we know that alpha plus beta is minus 7. So this will be minus 7 raised to the power of 2. Then alpha beta is 11. So this will be 2 times 11 over alpha beta, which is also what? 11. So we can say that the sum of roots will be, this is 49 minus 22 over 11. and this will be 27 over what? 11. So that's the sum of roots. Okay, now product of roots, that will be alpha over beta multiplied by beta over alpha, and this is 1. Okay, so the product of root is, so to form the equation, so we know that to form a quadratic equation, it will be x squared, okay, minus sum of roots of x plus product of root equals to 0. So this will be x squared minus the sum of root is 27 over 11 of x plus 1 equals to 0. So if we can multiply this equation by 11, then the new equation will be 11 squared minus 27x plus 11 equals to 0. So this is the equation. Okay, that's the equation we get when alpha over beta and beta over alpha are giving us the roots. Okay, so now the last question is for us to prove that alpha minus beta is equals to square root of 5. So we have to prove alpha minus beta equals to the square root of 5. So what we need to do in this case is, we know that when we consider square of a difference, okay, one of the algebraic formulas, okay, we know that square of the difference between the two roots will be equals to alpha square plus beta square minus 2 alpha beta. And for alpha square plus beta square, this is alpha plus beta square, okay, minus 2 alpha beta minus 2 alpha beta. Okay, for only this, alpha square plus beta square is square of alpha plus beta minus 2 alpha beta, and already we have this, which is minus 2 alpha beta. So when these are combined, we have the square of alpha plus beta minus 4 alpha beta. Now let's not forget that the product of root is what? 11, and the sum of root is minus 7. So we can say that minus 7 square, okay, then minus 4 times 11. This will be 49, okay, minus, this is 44. So 49 minus 44 is 5. So we have here that alpha minus beta square equals to 5. So if you take the square root, okay, of both sides, alpha minus beta to the square equals to the square root of 5. So this will disappear. So we can now have alpha minus beta to be equals to the square root of 5. Okay, proven. So now we just prove that the difference between the two roots, okay, of the quadratic equation is equals to the square root of 5. The noblest pleasure is the joy of understanding. Bye-bye.